بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about implicit differentiation section 3.5. Find dy by dx by implicit differentiation. So we find the derivative of this equation with respect to x. So the derivative of x squared is 2x. And now 4x times y, this is a product. So this is the first function and this is the second function. Remember the definition of the product, the derivative of the product is f prime times g plus f times g prime. So the derivative of 4x is 4 times y plus, but there is a minus now, okay? There is a minus here. So both terms would be a minus. 4x times the derivative of y, and the derivative of y is y prime or dy by dx plus y squared. Y is a function of x. Remember, y is a function of x, like x cubed plus 1 to the power 2. So using the chain rule to find y squared, you need to find the derivative of the outer function times the derivative of the inner function equals the derivative of 4, which is 0. That's it. Now we just need to solve for y prime to find dy by dx or y prime. So I will take y prime as a common factor from these two terms. And I will take these two terms to the other side. And then y prime or dy by dx would be equal to 4y minus 2x over, we divide by the coefficient of y prime. So this is y prime. Another question, derivative of x cubed is 3x squared. Here I have product. The derivative of x is 1. There is a minus sign, so the two terms would be negative. Or you can just write, if you like, take the minus outside, okay, and write plus in the middle. No problem. At the end, you will have negative, negative. So negative x times the derivative of y squared, which is 2y times y prime, because y is a function of x using the chain rule. Derivative of y cubed is 3y squared times y prime, because y is a function of x, and derivative of 1 is 0. Now, I will take y prime as a common factor from these two terms. So I have negative 2xy plus 3y squared. And these two terms, I'll take them to the other side. So I'll have y squared minus 3x squared. And then y prime or dy by dx would be equal to y squared minus 3x squared over 3y squared minus 2xy, or negative 2xy plus 3y squared. This is y prime or dy by dx. Well, here I have a quotient, so I'll use the quotient rule. If you remember the quotient rule, to find the derivative of f over g, you write g squared here, and then f prime g minus f g prime. So the derivative of the numerator is 2x times the denominator minus x squared, the numerator, times the derivative of the denominator. Derivative of x is 1, derivative of y is y prime. equals derivative of y square is 2y times y prime plus the derivative of 1, which is 0. Cross product, so I will expand this, x squared times 1 minus x squared times y prime equals 2y prime times x plus y to the power 2. Now keep this. Let me expand this also. 2x squared plus 2xy minus x squared would be equal to x squared y prime. I'll take this term to the other side, plus 2y y prime x plus y to the power 2. And then I'll take y prime as a common factor from here. So I have x squared plus 2y times x plus y to the power 2 equals, I will write equal from here instead from here. And I have in the other side 2x squared plus 2xy minus, well, 2x squared minus x squared is just 1x squared. So finally, y prime would be divided by the coefficients. So I will have x squared plus 2xy over x squared plus 2y times x plus y to the power 2. And that's the final answer. You cannot simplify more than that. The derivative of the left-hand side, I have a product function. Derivative of x is 1 times e to the power y plus x times. Derivative of e to the power y is e to the power y times y prime. The derivative of the inner function, because y is a function of x, equals derivative of x is 1, derivative of y is y prime. Now, I'll keep x, e, y prime in this side, and take y prime also to that side, and I'll keep 1 here, take e to the power y to this side. So now I can take y prime as a common factor. If you take y prime from the second term, you have 1 equals 1 minus e to the power y, and finally y prime is 1 minus e to the power y over x e to the power y plus 1. Derivative of sine x is cosine x. Derivative of cosine y is negative sine y times y prime, because y is a function of x. Derivative of 2x is 2. Derivative of 3y is 3 times y prime, because y is a function of x. So I will keep y prime, negative y prime sine y in this side, bring 3y prime to the other side, keep 2 here, take cosine x to this side, and take y prime as a common factor. So I have 3 minus sine y equals to 2 minus cosine x. So y prime would be 2 minus cosine x over 3 minus sine y. I have product in the left-hand side. Derivative of ex is ex times sine y plus ex times the derivative of sine y, which is cosine y times y prime, because y is a function of x using the chain rule. Derivative of x is 1, derivative of y is y prime. Okay, take all terms with y prime to the left-hand side. Keep the 1 and take ex sine y to the other side. And now take y prime as a common factor. So I have ex cosine y minus 1 And now I can solve this equation for y prime easily. And this would be the derivative dy by dx or y prime. Derivative of sine is cosine using chain rule times the derivative of the inner function. Derivative of x is 1, derivative of y is y prime. Derivative of cosine x is negative sine x. Derivative of cosine y is negative sine y. Derivative of cosine is negative sine times y prime because y is a function of x. Okay, here multiply, so I have cosine x plus y prime times cosine x plus y equals negative sine x minus y prime sine y. Well, keep y prime here and take it as a common factor from cosine x plus y. And this term, when it goes to the other side, you will have here sine y. I have negative sine x minus cosine x plus y. And finally, y prime would be negative sine x minus cosine x plus y over sine y plus cosine x plus y. And we stop here. We cannot simplify more than this. Derivative of tan is secant square. And now the derivative of the inner function. Here I have product. Derivative of 2x is 2. And derivative of y cube is 3y square times y prime. And derivative of 1 is 0. So I have secant square x minus y prime secant square x minus y expanding equals, let me bring this term, 2 times 3 is 6x y square y prime to this side and keep 2y cube here. Now I'll take y prime as a common factor from these two terms. So I have negative secant square x minus y, negative 6x y square, and this would be equal to 2y cube minus secant square x minus y. So finally y prime would be 2y cube minus secant square x minus y over negative secant square x minus y minus 6x y square. I can multiply by negative 1 up and down and write it secant square x minus y minus 2y cube over secant square x minus y plus 6xy square, and there is no cancellation whatsoever because there is a minus and a plus. All right. The derivative of the left-hand side product function, derivative of y is y prime. Derivative of cosine x is negative sine x. Derivative of x squared is 2x. Derivative of y squared is 2y times y prime. So I have y prime cosine x minus 2y y prime equals to 2x. This is negative y sine x. When you take it to the other side, it would be positive. So you can take y prime as a common factor here. And then y prime would be 2x plus y sine x over cosine x minus 2y. Derivative of sine is cosine, and then we multiply by the derivative of the inner function. But the inner function is product x times y. We use the product rule. Derivative of x is 1. X times derivative of y is y prime. Derivative of cosine is negative sine times the derivative of the inner function. Derivative of x is 1. Derivative of y is y prime. Now I need to expand y cosine xy plus xy prime cosine xy equals negative sine x plus y times 1 minus y prime times sine x plus y. Take y prime to the other side and take it as a common factor. So I have x cosine xy plus sine x plus y. And in this side I have negative sine x plus y, and also I'll bring y cosine xy to this side. So y prime would be negative sine x plus y, negative y cosine xy over sine x plus y plus x cosine xy, and that's y prime, no cancellation. Product function. Derivative of 2x is 2. Derivative of ey is ey times y prime. Another product. Derivative of y is y prime. Derivative of ex is ex. Derivative of 3 is 0. I take y prime as a common factor. I have 2x e to the power y plus ex, and I take these two terms to the other side. Then y prime would be, you can see that if you understand the derivatives and the chain rule, then solving for y prime is somehow similar in all of the previous questions. Derivative of square root is 1 over 2 square root times the derivative of the inner function equals derivative of x to the power 4, 4x cubed. Derivative of y to the power 4 is also 4y cubed, but times y prime. So I have what? Let me multiply by this square root. So 1 plus y prime equals 4 times 2 is 8x cubed square root of x plus y plus 4 times 2 is also 8y cubed y prime square root of x plus y. And now I have y prime here and y prime here, so I'll take this term to the other side, and I'll take y prime as a common factor. So I have 1 here minus 8y cubed square root of x plus y. This would be equal to, this one will come here, so it would be negative 1 plus 8x cubed square root of x plus y. So finally, y prime would be negative 1 plus 8x cubed square root of x plus y over 1 minus 8y cubed square root of x plus y. No cancellation because there is a plus and minus. That's the easiest form, the simplest form. The derivative of the left-hand side is e to the power x over y times the derivative of the inner function, which is x over y. I use the quotient rule, y squared. Derivative of x is 1 times y minus derivative of y is y prime times x equals derivative of x is 1, derivative of y is y prime. Well, I will multiply by y square. Okay, so I'll have y e x over y minus x y prime e x over y equals y square minus y square times y prime. I multiplied by y square to get rid of this y square. So now I have negative x y prime e to the power x over y plus y square y prime equals y square minus y ex over y. So take y prime as a common factor and then divide. So I will have y square minus y e to the power x over y over negative x e to the power x over y plus y square. And that would be the final and the simplest form. No cancellation. Derivative of cosine is negative sine. And now with the derivative of the inner function. Derivative of x squared is 2x, derivative of y squared is 2y times y prime. This is also products derivative, or it is the first product, okay, in this question. Derivative of x is 1, x times the derivative of e to the power y, which is e to the power y times y prime. I need to solve for y prime. So I will have negative 2x sine x squared plus y squared minus 2y y prime sine x squared plus y squared. And let me bring this term here and keep e to the power y there. Now I will take y prime as a common factor from these two terms. So negative 2y sine x squared plus y squared minus x e to the power y equals e to the power y plus 2x sine x squared plus y squared. So y prime would be equal to e to the power x plus 2x sine x squared plus y squared over negative 2y sine x squared plus y squared negative x times e to the power y. I can keep it like this. No cancellation, of course. All right. Find f prime of 1. Well, this is f of x, so let me find f prime of x. Okay. So we need to find the derivative of this function, of this equation. I'll find the derivative of this equation with respect to x. So derivative of f is f prime of x plus. Now here I have product. Derivative of x squared is 2x times f of x all to the power 3 plus x squared times the derivative of this, which is 3 times f of x all to the power 2 using chain rule times the derivative of the inner function, which is f prime of x, equals 0 because the derivative of 10 is 0. Now I need to find f prime of 1. So f prime, I can solve this equation for f prime of x, and I can do it like this. I can replace x by 1, okay? I can replace x here now by 1. So f prime of 1 plus 2 times 1 times f of 1 to the power 3 plus 1 square is 1, f of 1 to the power 2, f prime of 1 is 0. Okay. Now, what is f of 1? F of 1 is 2. Okay, so here I have 2. 2 to the power 3 is 8. So this is 2 times 8. And here f of 1 is 2. 2 times 2 is 4. So 3 times 4 times f prime of 1. Okay, and here f prime of 1 equals 0. So this is 3 times 4, 12. 12 f prime of 1 plus f prime of 1. So I have 13 f prime of 1 plus 2 times 8, 16, or I can take 16 to the other side. So f prime of 1 is negative 16 over 13. You can do it like this, or you can solve this equation as we always do for f prime, okay? You take f prime of x as a common factor. So is there a space? Yeah, there is a space. I will solve it in this other method. So I will take f prime of x as a common factor, and I have 1 here plus 3x squared times f of x all square. All right. And now take negative 2x f of x all cube to the other side. So f prime of x would be equal to negative 2x f of x to the power 3 . Okay, this is 2. And I have here 1 plus 3x squared f of x all to the power 2. And now you can find f prime of 1 by replacing x by 1. So again, negative 2 times 1 is negative 2. And f of 1 is 2, if I remember. Yeah, f of 1 is 2. So I have here 2 to the power 3. And here 1 plus f of 1 is 2, and x is replaced by 1. X is 1, so this is 3 times 1 square is 3. And f of 1 is 2, so 2 to the power 2. I have negative 2 times 8, 16, and 3 times 4, 12, plus 1, 13, and you will get the same answer. Find g prime of 0. Well, I will find the derivative of this function with respect to x. So derivative of g of x is g prime. And here I have product. Derivative of x is 1 times sine of g of x plus x times. Derivative of sine is cosine. Cosine of g of x times the derivative of the inner function, which is g of x, so times g prime, equals derivative of x squared, which is 2x. Again, you can solve this for g prime, or you can find immediately g prime of 0. So I'll find immediately g prime of 0. I'll replace x by 0. So I have g prime of 0 plus sine g of 0. Okay, but we don't have here g. Okay, so I need here to find g of x from this equation. So here I can take no, I can't, because this is sine g of x. It's not product. Okay, to find g of 0, let me replace x0 here in this equation. So g of 0 plus x0, x is 0, so 0 times sine g of 0 equals 0 square, which is 0. This would be 0, so g of 0 is 0. Okay, So simply g of 0 is 0. Good. So sine g of 0 would be sine 0, but let this be in the next step. X is 0 times cosine g of 0, g prime of 0 equals 2 times 0, 0. So 0 times anything, this is cancelled. And sine g0, g0 is 0, so sine 0 is also 0, so this would be cancelled. So g prime of 0 would be 0. So g prime of 0 is 0. All right. Yeah. All right. Use implicit differentiation to find an equation of the tangent line to the curve at the given point. Well, this is 0, 0, so the equation y minus 0 equals the slope times x, where the slope is the derivative, the first derivative at this point, 0, 0. Okay, you can write m as dy by dx at the point 0, 0. Well, the derivative of the left hand side product, so derivative of y is y prime times e to the power sine x plus y times the derivative of e to the power sine x is e to the power sine x times derivative of sine x is cosine x. All right, equals. Also, I have here products. Derivative of x is 1 times cosine y plus x times the derivative of cosine, which is minus. That's why I kept minus here. So negative sine y, derivative x as it is, derivative of cosine y is negative sine y times y prime. Now, I need to find y prime at 0, 0. So let me replace x by 0 and y by 0 in this equation. Sine 0 is 0, e to the power 0 is 1, so I have y prime plus y is 0, so this term is cancelled. Cosine 0 is 1. X here is 0, so this term is cancelled. So y prime is 1. So the equation is y equals 1 times x, or y equals x. The equation of the tangent line here, y minus 1 equals the slope times x minus 2. Okay, where the slope is the derivative at the point 2, 1. Derivative of x squared is 2x. This is product. Derivative of x is 1. There is a minus sign, so there will be minus here also. Negative x times the derivative of y, which is y prime. Derivative of y squared is 2y y prime. And derivative of 1 is 0. Let me replace x by 2 and y by 1. If you want, you can solve it for y prime and then substitute with x2 and y1. I'll do it from here immediately. 2 times 2 is 4. Y is 1. X is 2. Minus 2y. Y is 1. Equals 0. So 4 minus 1 is 3. Negative 4y prime, take it to the other side, it would be 4y prime. So y prime is 3 over 4. So this is the equation of the tangent line. Similar, y minus 1 equals mx minus 2. Let us find the derivative. Derivative of x squared to x plus product. Derivative of 2x is 2. Derivative of y is y prime. Derivative of 4y squared is 8y y prime equals 12, derivative of 12, which is 0. Good. X is 2, Y is 1. 2 times 2 is 4. 2 times 1 is 2. X is 2, 4y prime. Y is 1, 8y prime. So I have 12y prime, 4 plus 8, and this is 6. Take it to the other side. So y prime is negative 6 over 12 or negative half. So this is the equation of the tangent line. Find y double prime. Simplify where possible. All right. Derivative of x squared is 2x plus 8y times y prime equals derivative of 4, which is 0. I will solve this equation for y prime. So I will have negative 2x on the other side, and then I will divide by 8y. So y prime is negative x over 4y. And now let me find y double prime. Quotient rule. Derivative of negative x is negative 1. Minus times minus x would be plus, and derivative of 4y is 4y prime. So minus x is x, and derivative of 4y is 4y prime. Well, that's the answer. You can leave it like this, or you can write it in terms of x and y only. So you can say negative 4y over 16y squared, okay, plus 4x over 16y squared times y prime, and y prime is negative x over 4y. So I have negative 1 over 4, and y squared minus y is just y. And here I have negative 4 over 16 is, oh, this is 4 cancels with this 4. So I have negative x squared, x times x over 16 y to the power 3. And I can leave it like this. This is y double prime. Same question, find y double prime. So 2x plus derivative of x is 1, derivative of y is y prime, derivative of y squared is 2y y prime. Let me solve this equation for y prime. So I take y prime as a common factor. I have x plus 2y, and negative 2x minus y would be in the other side. And then y prime is negative 2x minus y over x plus 2y. And let me find y double prime using the quotient rule. Derivative of the numerator, negative 2 minus y prime times x plus 2y. Derivative of the denominator, 1 plus 2y prime. Derivative of 2y is 2y prime times negative 2x minus y. Let us simplify. So y double prime is equal to x plus 2y squared. I keep it as it is. Expand. Negative 2x. Negative 2 times 2y, negative 4y. Negative xy prime. Negative 2y y prime. Minus 1 times negative 2x, so plus 2x. Minus 1 times negative y, so plus y. Minus 2y prime times minus, so plus 4xy prime. Okay. Then minus times minus again, plus 2y y prime. Well, I can see that 2y prime cancels, and here I have negative xy prime and 4xy prime. I can add them together, and 2x cancels with negative 2x. So I will have negative 4y plus y is negative 3y, and negative xy prime plus 4xy prime is plus 3xy prime over x plus 2y y square. I can leave it like this, or if you want, you can replace y prime by this, okay, and simplify more, but it's okay in my opinion to leave it like this. Find the value of y double prime at the point where x is 0. Okay, I will solve this in another way. Find the derivative. Derivative of this product, derivative of x is 1 times y plus x times derivative of y is y prime, derivative of e to the power y is e to the power y times y prime, derivative of e is 0. This is a number, e, just e, 2.7. And now I'll find y double prime. I will find the derivative with this, again, the derivative of this equation. So derivative of y is y prime. Here product, derivative of x is 1. Derivative of y prime is y double prime. Here also products. ey, derivative is ey times y prime times y prime also, plus ey times the derivative of y prime, which is y double prime, equals to 0. So now put x equals to 0. He says where x is 0. I will have 2y prime, okay, this is 0, cancels, plus ey times y prime square, okay, plus ey times y double prime equals to 0. Well, I need to evaluate, find the value of y double prime. So I need to find y, the value of y, and the value of y prime, okay? So go back to the original equation. This is the original equation, xy plus ey equals e. Put x equals to 0 because we need x equals to 0. What would you have? E to the power y equals e to the power 1 because this is e to the power 1. So y is 1. Good. So I find out that y is 1. So this would be, it would do what? I have 2y prime plus e now because y is 1. Y prime square plus e y double prime equals to 0. Still, I couldn't solve for y double prime because I have y prime. So let me find y prime when x is 0. So go back to this equation now. Y plus x y prime plus ey times y prime is 0. Put x 0 and y 1 in this equation. Y is 1. X 0, so this would be cancelled. E to the power 1 times y prime is 0. So ey prime is negative 1. So y prime is negative 1 over e. All right. So put here y prime negative 1 over e. So 2 times negative 1 over e plus e times y prime square would be 1 over e square, isn't it? Okay. Plus ey double prime equals 0. Well, this is negative 2 over e plus 1 over e. So in fact, it is negative 1 over e. And I can, to solve for y double prime, I'll take negative 1 over e to the other side. So it would be 1 over e. And now I can divide by e or multiply by 1 over e, and y double prime would be 1 over e square. So when x is 0, y double prime is 1 over e squared, but we needed to find y, the value of y, and the value of y prime when x is 0. So we needed to use the original equation and the first derivative also. Thank you very much. I hope you enjoyed implicit differentiation.